Okay, so we're going to look at the characteristics of the sum and difference of functions. So because we are now combining functions, certain characteristics may be changed. So these characteristics that we're going to look at include the domain, the range, maximum and minimum values, or the existence of a maximum and minimum, and as well as symmetry, whether the function is odd or even. Okay, so let's start with the domain. The domain of the sum and or difference is defined only where the domains of f of x and g of x overlap. So what that means is, if you have two functions, and the domain of one of them is all real numbers, and the domain of the other one is values of x that are greater than 5, then what that means is, the domain of the combined function, whether you're adding or subtracting, can only exist for the domain where the two functions overlap. And so the only part of the domain that the two functions would overlap is when x is greater than 5. Okay, so all real numbers can't work because this function doesn't exist for values of x that are less than 5. It only exists for values of x that are greater than 5. Okay, so when you're looking at domain, the domain is only defined where the domains of f of x and g of x actually overlap. Okay, in terms of the range, restrictions on one or both of the original ranges will indicate the existence of a restriction or restrictions on the range of the resulting function. So it's a similar idea to the domain. If there is a restriction on the range for one function or for both functions, then the combined function will have those same restrictions on it as well. Okay, so maximum and minimum. So a local maximum in one or both of the original functions will produce a local maximum in the resulting function, or a local minimum in one or both of the original functions will produce a local minimum in the resulting function. So what that means is, if there was an existence of a local max or min in the original functions, or in one or both of the original functions, then the combined function, through addition or subtraction, will also have a local maximum or local minimum as well. Okay, so the existence of the local max and min don't change, they still exist. They may not be at the same place, or in other words, for the same value of x, but they will exist somewhere in the graph. Okay, the last part is the symmetry of the function, and this is the one that's a little bit more interesting. Two even functions will produce an even function. So what that means is, if you started off with two even functions that you're combining through adding or subtracting, then the final graph, or the final function, the combined function, will still be an even function. Same goes for odd functions. Two odd functions will produce another odd function. So if the original functions were odd, then the combined function is also odd. However, if you have an even function and an odd function being combined, then your combined function will be neither even nor odd. Okay? And we'll look at why that happens algebraically as well. If you think about it, algebraically, an even function would have an exponent that is even. An odd function would have an exponent that's odd. And if you combine an even exponent function to an odd exponent function, then it becomes neither even nor odd. Okay? Think about the example, if f of x was x squared plus 4, that's an even function. And if g of x was x cubed. If you combine these two, either through addition or subtraction, you'll end up with a function that's neither even nor odd. Okay? Two functions that are neither even or odd may result in an odd, even, or neither function. So the other one that's a little bit interesting is, if you combine two functions that originally were neither even or odd, you may end up with a new function, the combined function, that ends up either being even or it ends up being odd. So here's an example. So here's a cubic function. Okay? This is neither even nor odd. Remember, if you plug in x as negative x instead, you'll notice that this is not going to be an even function or an odd function. And here's g of x. Again, this is neither even nor odd. You have an even exponent and an odd exponent, which automatically you know will end up not giving you an even or odd function. However, if you combine these through addition, so if I add the two functions together, I end up with an even function as a result. Okay? So a neither function, so two functions that are neither even nor odd, if they get combined, there is a possibility for it to result in either an even function or an odd function, or again, neither even nor odd.